Okay, one more time. So you've torn off a little piece of paper, and this little piece of paper is going to be used for rotations, okay? It's a little cheat sheet for doing rotations, and it's very simple to make. We draw a graph, right? Just the two axes. We have our x, right, where all of our x values are positive to the right there, and we have our y, where all of our y values are positive going up, right? That also means on the other side, this is still our x-axis, where x is negative, and this is where y is negative. Any questions on that? Okay, that should be totally clear. So the way you're going to use this is like with our bell ringer, and there'll be a certain degrees, a certain number of turns, 90, 180, 270, or 360, and a direction to the right or to the left. Now instead of saying to the right or to the left, they say clockwise or counterclockwise, right? So let's start with 90 degrees clockwise. If we're going to do 90 degrees clockwise, put your pencil on the center so it kind of can spin easy. Pencil in the center. And then clockwise. Now clockwise is to the right, right? Like a clock ticks, tick, tock, tick, tock. So we're going to turn the paper to the right one turn, because that's 90 degrees is one turn. And that's why I want you to think of these degrees as the number of turns. All right. So our answer is right in front of us. What is it? Where our original x value was and our original y value is how our rule is being transformed. So I'm going to back to where we started. Typically, you write ordered pairs like this. X, comma, y. That's the standard form, right? When we do and that comes from this. This is x, positive y. X, y. It's to the right and up. When we turn it 90 degrees to the right, 90 degrees clockwise, what is in our original x location? This positive y, so we're just going to write y. What is in our original x location? Our original x location is y. Our original y location is negative x. So our rule is take whatever you have, flip their places, and flip x's sign. You can see how that would get complicated real quick, and you may not understand it yet, but I want you to be able to just have this in front of you because we're going to use it for all our problems today. Okay, so that's 90 degrees. You can imagine if I was doing 180 degrees, I'd start at the top. 180 clockwise would be one turn. 180 is two turns. And then I do the same thing. Negative x, negative y. That's 180. And then 270 would be three turns. 1, 2, 3. That's three turns, where my answer would be negative y. So negative y first, and then x. That's how you're going to use this, okay? So let's do a few problems with it now. First of all, rotation. We all understand the concept of rotating something, so we don't need to go into that. It turns a figure around a fixed point. That fixed point for us is going to stay as the origin. Does anyone remember what origin means?
It means the beginning.
The beginning. It means beginning. And it's on the y-intercept. And it's 0, 0 is the coordinates, right? It's the very center, the bullseye of the graph, okay? In terms of what's preserved, location is not preserved, size is preserved, and the way it's facing, the orientation is not preserved. Okay. We're going to be turning to the right. You can think of that. You know, like if you use a screwdriver ever, righty-tighty, lefty, lefty-loosey, right? Or to the left, but it's going to be with the clock, right? Clockwise versus counterclockwise. Okay, and each rotation is one turn. So this is how I want you to think about it. We've got 90, and you need to write 180 degrees, 270 degrees, and 360 degrees. These are the only degrees you're going to be asked to rotate something. Good. 90 degrees is one turn. 180 is two turns. 270 is three turns. And then obviously 360 would be four turns. Okay, so as long as you know that, you know your directions, left and right, clockwise is right, counterclockwise is left, and you know how many turns, and you have your little paper that you made, you should be fine on these problems. So I'm going to do the first one. You can kind of just watch, but kind of copy what I'm doing, you know. So this first one, it's a 90 degrees clockwise. So that's one we already did. So let's do it again. 90 degrees clockwise means I'm always looking at what are these two values, right? Where my x is originally and my y is originally. Well, I'm going to rotate it 90 degrees to the right. So that's one turn, turning clockwise. Y is now in the front. Still positive. Y is in the front. It doesn't get a sign flip. And x is now where y was. So this is what the rule looks like. So down where it says algebraic representation, we're going to do that first. Originally, it's always an xy pair, just like it has been for years, right? What does the change look like now? The pattern is going to look like this. All of our values, they're going to switch places, and our x value, our original x value, is going to get a sign flip. And we saw that with reflections, right? The negative just means flip the sign. So without even looking at the graph yet, we already know what our pattern is. We're going to go over to our pre-image. Right? Negative 2, 1. They're going to switch spots. So 1, right, our y value, this is xy, is now in the front. And our x value is now positive 2 because it got a sign flip. Right? It was negative 2 in the front. Now it's in the back and it's positive because it got a sign flip. Any questions on that? The next one, same thing. They're going to switch spots. Just follow the pattern. Switch spots. And the first value gets a sign flip. X is now positive 2 here. Negative 6 and 1, same thing. X, right? Y, and then it's y negative x. So 1, comma, positive 6 is going to be our new value. Right? Now let's look at what this looks like on the graph. You can always check your work as long as you know how to rotate something. 90 degrees clockwise means that it should end up in this quadrant, right? Quadrant 1. That's 90 degrees clockwise. Okay. Then you plot your points. If this was A prime is at 1, 2. If this was B prime is at 7, 2. And this was C prime is at 1 and 6. Okay. And you'll see the exact same shape, right? If it got disfigured or something, then you know you messed up one, right? Which happens. So just use common sense here to check your work, right? And you can see this looks like a rotation 90 degrees to the right, right? All our points are in the first quadrant there. That's it. And the nice thing about this is we don't really even have to worry about a rule. In fact, I'm just going to say cross that out. Okay. The little blank up here, if you're curious about it, it says rotating 90 degrees clockwise. That would be the same as rotating 270 degrees, 1 turn, 2 turns, 3 turns, counterclockwise, right? Which, don't think too hard about that. That's just, saying you could go backwards or you could go forwards, right, around a circle and you end up at the same spot. Okay. Questions on this? Okay, I'm going to stop the recording.